Hello, I'm Keith Danica with Apigee, which is part of Google Cloud Platform. Welcome to our Apigee Up-Close webinar series. We're planning webcasts twice a month on various topics based on demand. We'll cover security, monetization, extensibility, and analytics, and other topics. You can ask questions live, and you can sign up for multiple webcasts. So this week, a few people have asked about how to integrate existing identity management systems into their APIs. So I'll be showing an example of that. You can enter questions, and I'll answer them after the demo. So here's our agenda for the day. I'm going to do a brief overview of Apigee Edge. We're going to talk about identity management integration, and I'll show a demo of that. And then we're going to do question and answer. So first, a quick overview of Apigee Edge. So this describes the philosophy of our platform. We've seen a repeated pattern of success with our customers, and it's driven by how they think about the problem. It requires a shift in how you think about this. So traditionally, we've thought about this from an exposure point of view. We can just expose a service and we're done. Thinking about it from the end user's point of view leads us to much better results, though. Our successful customers start from the user there on the left, thinking about what that user's experience will be like and working backwards from there. Providing the application developer with great APIs will reduce the complexity of creating new applications. And the developer is free to focus on user experience, iterate on a few different designs, try things out. The API team makes that possible by providing easy-to-use APIs with consistent interfaces and security. Today, we'll talk about how to make that security consistent. The API team is going to build a facade on the existing services, and they're going to abstract away the complexities. Apigee Edge makes that easy for your API team and makes it easy to build great APIs. And Apigee Edge also makes it easy for those developers to consume APIs. And it also lets you measure every aspect of your API program. So let's talk about what's in Apigee Edge. Apigee Edge is a single platform with three conceptual parts. API Services lets us expose and manage services as an API. Developer Services provides a portal where our application developers and API consumers can learn about APIs and request access to them. And Analytics Services lets us measure every aspect of the API program. So let's look at each of those in a little bit more detail. So API Services is where we're going to build APIs. That's what we'll see mostly in the demo today. On the left, we have applications, maybe a mobile application, a web application, or a partner system. These applications make API calls. They send HTTP requests. Apigee Edge lets you pass the request straight through the backend system, or you can change anything in the headers, the URI, or the body. You can even do intelligent routing based on the caller. You can also manage the flow of traffic by imposing rate limits or quotas, and you can apply caching. When the backend system returns a response, you can send that response straight back to the application, or change it as needed. For example, you might send a reduced payload to a mobile client, or transform XML data into JSON. So after you build some great APIs, you want to make it easy for the developers to discover them and to start using them. The developer portal gives you a place to put your documentation and tools, and to let developers register for access. With Smart Docs, people can try out your APIs from the documentation. They can fill in the data fields and see what the request and response flow looks like. The developer portal reduces the friction when getting started with your APIs. So after you've built a few APIs and your application developers have discovered them and started to send you traffic, it'd be great if you could measure your API program. The analytics system in Apigee Edge allows you to measure every aspect of your API traffic. You can measure operational details like response time, frequency of different types of errors. You can find things that are interesting to your business, like where are people located and when they call your API, or which applications are sending the most traffic. Maybe it's interesting to see what kind of client they're using. Are they on iOS? Are they on Android, Firefox, Chrome, that sort of thing. So let's talk about a common request that I hear from customers. How can we authenticate using our existing authentication system? We've got something in the back end. We've got SiteMinder, we've got Okta, we've got Tivoli, we've got Oracle Identity and Access Manager, something like that. And we'd like to use that to authenticate end users. And in addition to that, we've got some back-end systems, and a lot of them have different techniques for authenticating against them. So how do we manage all that? How do we connect it all? So here's the problem, or problems. There are a few different types of authentication we might need to consider when we're building APIs. We may just need to identify which application is calling our API. Is it a website application? Is it the iOS app? Is it the Android app? But in addition to knowing which application is calling our API, we might need to authenticate the end user who's using the application. Also, our back-end services might require some sort of authentication. In a lot of cases, we want to separate front-end authentication from back-end authentication. We may have a variety of different authentication mechanisms on the back, but we want to provide a single, consistent way of authenticating when you call an API. We may want to hide the gory details of back-end authentication from our API consumers too. You might have multiple ways of authenticating calls to those back-end services, depending on which back-end service you call and when it was built. So let's consider an example where we need to authenticate end users using Okta and call a back-end service using a service account that requires a username and password in the form of basic authentication. We'll prompt the username for their Okta username and password, and we'll store the username and password for the back-end system in Apigee's key value map. So here's a few more details on how that might work. So if we look on the left here, we've got an application. So there's our application over here. And the typical flow for this, in the happy case, is going to be that somebody's already authenticated and they have an existing OAuth token, and they'll send that in. So first we're going to check that token. We might apply a spike arrest to shut them down if they call too quickly. We're going to remove that authentication header that was sent in for our OAuth token check. And then we're going to go look up the username and password for the backend system. And we'll use the set basic auth policy to install a basic auth header and then send that along to the backend system. So where did we get that token? If we call this the first time and we don't have a token, this is going to return a 401 error. And our application is going to realize that it doesn't have a token, and it's going to make a call out to the token service, which is on a different URL. So token service is represented down here. We call that with the username and password. And in this case, we're going to use a service call out, and we're going to call Okta with that. And from there, we're going to pass in the username and password to the API that's provided by Okta for this. And it's either going to return a 200 or a 401. If it returns a 401, we'll return that back to the user and say, hey, that's not the right username and password. Let's assume it's good, sends back a 200. We're going to skip this next policy. That's a custom flow for sending a specific error message. We'll get the session ID that came back from the Okta response. We'll set some keys in there. And then we're going to generate an OAuth token using Apigee's OAuth token generator. So that's a bit to digest. I'll go into the details on how this works in the first place. But the general thing is, this is the business flow on the top. We're going to check that token when we come in. And if it's good, everything continues. If it's not good, we're going to go out to this token flow on the bottom, and we'll get a token from there. Okay, so let's look at the API in a little bit of detail behind this, and let's see how that's built in Apigee Edge. So here's our API. The first step in here is we put it in OAuth 2 policy in there to check a token. So we're assuming that you've gone and retrieved a token from another flow and that you have an access token. So the first step is to check that, make sure it's working. So we'll notice that this is in the verify access token mode. We've got a spike arrest in here to prevent you from calling too fast. I've set it to 10 per minute just as a demo. And then we've got this in here to remove a header. So this assign message policy in here, it will remove the header and it's going to remove the authorization header. So why do I have that in there? Well, when you call this, you're going to send in an authorization header, and that's checked by this first policy. But we don't want to send that to the back end. We don't want to send that same authorization header to the back end. We're going to send a different one. So I'm just going to remove this one, and then we're going to put a new one on there. This next step in here is I'm going to look up the username and password for that service identity. So for that service account. So I've put those in the key value map for Apigee Edge in here, and you can find those in the environmental settings. And within there, we'll look up the username and the password, and that will load these into private employee dir user and employee dir password. And then next, we're going to call this policy here, the basic authentication policy, and we're going to set the username and password to user and password. And that's going to build us a new header called authorization. So that's the brand new authorization header. And that's basic auth. So it's base 64 encoding of the username and password with a colon between them. And then that gets sent to the back end. So we have one identity for the user. That's what we're checking here. And then we're building a new identity to send in as a header to the back end. That'll let us in, and that'll allow our application to show us results. So that's how this works. Next, let's look at the token flow. So I've loaded up the flow for the token. So this would be called running on a different URL, and this would be the flow that you're going to call in order to obtain a token. So I've got a spike arrest policy in here just to prevent people from calling this too quickly, but the main business is down here in this function down here called token. So if we call /token with a post operation, this logic will be executed. So let's look at this in a bit of detail, and let's see how this works. Okay, so the first step in here is we're going to do a service call out to Okta. Now, there's a lot of different ways to do authentication with Okta. It's a very full-featured product. It can do single sign-on to a lot of different systems. What I'm doing here is the absolute most simple thing you can do with it. I'm assuming that our back-end system is using some service account that isn't connected to Okta in any way. And really what I want to do is just validate that this user exists. Their username and password exists within Okta. So I'm using it as a very simple identity management system. The way we do that is there is an API for that. And here's the URL for it down here. Now, the first part of this is my developer instance on Okta. You can go up and sign up for a developer account on Okta. That's what I did. I get a custom URL. The API we're calling is /API v1 authn. And you pass it a username and password, and it returns a 200 if that user is good, or it returns a 401 if that username and password is not valid. I'm building up the request up here, so we have to send it a JSON request. Application JSON is the content type there. And we're going to send it over a post, HTTP post. And then there's the payload down here. This is a JSON body. Now we use curly braces within Apigee, so we have to prefix those with these ats down here. So that's what this at and pound sign over here are doing. We can't have curly braces within curly braces because it confuses our parser. So that's what's happening there. So the body we're building up is curly brace username and then, curly braces in there like you'd expect. So we've assumed that this has been called with the username and password, and we've done a form encoding of that, and that's been passed into this API proxy. We're going to grab those out of that request, and then we're going to forward them on and build this JSON request here for Okta. We're going to put the response in Okta response, and we're going to allow 15 seconds for it to complete, and if not, we're going to throw an error. So that's what we're doing in there. This next step, I've got a condition on this. This will only show up if we get a 401 back from Okta, if we get a bad auth. And it's going to say invalid username and password. We'll get some other information back from Okta. So in this case, we're going to look at the Okta response. What do we get back? We got back a 200 code, but there's also a session ID in there. So we're going to grab that just for fun, and we're going to stick that on our access token. In the next step here, I set the client ID in secret, and that's going to allow me to generate a proper OAuth token for this particular API product. Now, there's a lot of different ways to do this. There's a lot of debate on what do you do with your key and your secret and that sort of thing. In this case, I'm just requesting the username and password for somebody. But in order to generate an OAuth token, you've got to have that username and password. You also have to have the key and the secret for the Apigee API product you're using. And that's what I do in that next step. And then finally, we generate a token. So what we're doing in here is we've got the OAuth policy, but we put it into the generate access token mode. And it's doing a password grant in the OAuth spec here. So what we're going to do in here is that's going to generate a OAuth token. We have the option to put an expiration time in here on how long we want that token to last. Maybe it's 30 minutes or 60 minutes. I haven't set that, so it's just going to go with whatever the default is set up for Apigee. And that's system-wide. I'm going to stick some custom attributes on there. So you can stick whatever kind of custom attributes you want on your OAuth tokens that Apigee generates. Whenever they come into the system, those attributes will be populated as variables, and you can use them for any kind of conditional flows you want, dynamic routing, whatever you want to do. So in this case, I'm going to grab the username, and I'm also going to grab that session token from Okta, and that's going to be stuck onto my token. So this is the process for generating a token. So let's look at this in a little bit more detail. This right here, what I've got loaded up is just an environment where I can call APIs directly. This isn't Apigee. This is just a program for calling URLs. So I'm sending in the credentials to Okta. That's on another screen we can't see. And when I make a call into here, I get back a session token. I get back some other information about my user, who they are, where they live, that sort of thing. So that's the call straight to Okta. Now, when I call the Apigee API, it's going to make this call out right here that we're looking at. So on this screen here, what we're seeing is the response from the Apigee proxy. So this is calling in, it's testing our user against Okta. If that user's good, it continues on, it generates an Apigee Edge token for us, an OAuth token. And that's what we're seeing in here. So what we see in here is there's a few extra attributes on here. We've got, let's see, where is our tokens? There's our access token in there. And then we've got this username down here, and we can see who the user was. We might want that identity. We want that to show up in Apigee. Maybe we do routing or logging or something based on that. But this is the access token we're getting back from Apigee. So why do it this way? Why not just call it to Okta every time, see if the user's good? Why do we need to involve generating an OAuth token based on that? Well, a few different reasons for that. One is we want to put a facade on here. So we might have a lot of different ways to authenticate users. We're going to standardize on OAuth tokens. And no matter what the back end is, no matter what the front end authentication mechanism is, we're just always going to send out an OAuth token, and that's a lot easier. By using Apigee's system for this, for generating tokens, we're completely integrated with Apigee in there. So these tokens, when they come through, it's not just simple authentication. They also load up any kind of parameters that might be associated with that. So we know what API product they're using, what developer application this is, who the user is, things like that. Any kind of metadata we stuck on there, like you saw that we stuck the Okta username on there. That's all available to us. So we get identity, but we get a bit more. We can also have different policies based on which API product they're using. We might want to enforce rate limits and quotas and things like that. That may be coming from our API product. So that's the reason why we want to use the Apigee token in this case. Also, it's going to be a lot faster to validate those. We don't have to make a full call out to Okta's API. It's about 1 millisecond to check the OAuth token in here. So that's why we're doing this. And, just to repeat, what we're doing is OAuth token on this side, and then whatever it happens to be on the back end. In this case, it's a service account with user basic or username and password as a basic auth header. Now let's consider how we would do this if the backend service was running in Google Cloud Platform. You can create service accounts in GCP that only have rights to specific sets of services. When you create that service account, GCP will generate a file with credentials that can be used to get an OAuth token for that service account. Let's assume we've uploaded those credentials to a KVM in Apigee Edge. For more details on this process, you can check out an example developed by my colleague Dino. I'll cover the process at a high level here, but Dino goes into great detail and has code samples out on GitHub. So I'll post a link for that. I'm going to show the high level today, and I'll post a link to the example that Dino created that shows how to do this. I based mine off of that, and you can too. So what are we looking at in here? We've got a lot more steps in here. So what's different about this is we need that credential for the service account on the back end. So business flow is the same. We've got something on the front, an API key check or an OAuth token check on the front of there. But this time we've got a flow callout, and that's calling out to a shared flow. And I've put the validation process for talking to Google's identity and access management system and obtaining that token. I put that into a shared flow because I use it in a lot of my different demos. So basic steps are, if we work backwards in here, it needs to set a header, and it needs to have a bearer token. So it should say, we should have an authorization header in there, and it should say bearer space, and then that token value. So we have to have a token that we get from the identity management system, in this case, Google Identity Access Management. So go back into here. What I've done is, after I get that value, I'm caching it. So first thing you do is check and see if it's already in the cache. Maybe there's already one that's there. If so, you skip all these steps in between, and then this last box in here, this last policy, simply sticks that header in there. So assuming it's not in cache, we're going to look up the key and secret that we need from the key value map in Apigee Edge. We're going to call a Java callout. That's going to encrypt this just the right way. It's going to build a very specific JWT that we send out to an API on Google that provides API tokens, or provides OAuth tokens. This is a service callout to do that, similar to what we saw for Okta. And then we're going to get back the access token. We're going to pull that out of there. Some JavaScript to change the timeout on that, the time to live, error code handling, and then stick it in the cache. And then finally, this last step in here, we're going to assign that to a variable so we can find it. That's our test to see if it's available. And then we're going to stick that in the header. So that's the process for that. Shared flow in this case. So in our business flow, rather than having all these different steps in here, we just do a call out because that's something we're going to reuse again and again. And in this case, we're going to do identity management on the front end here with an Apigee OAuth token, and we're going to do a GCP OAuth token on the back end in order to talk to that service. So let's look at this one in Apigee Edge and see how it works. So let's look at our shared flow and how we log into Google Cloud Platform in a little bit more detail. So I'm back here in Apigee Edge. First thing I want to show you is the key value maps. So I'm going to click over here, and we're going to look at the environments. So I've got some caches in here. I've got some flow hooks. Key value maps is what we want to look at. So I've created a key value map in here called secrets1. And in there, I keep my secret things. So I have some usernames and passwords for various demos that I work on. But you'll notice down here, here's a GCP private key PEM. And so that's a value that I need in order to generate, in order to build that JWT that I'm going to send over to Google Cloud Platform's identity management platform. So that's where I get that from. So you can have different values for test and for prod, for example. You can store things in here that you need. There's encrypted versions and then not encrypted versions. And check the docs for that for all the details on how this works. So let's go back over to the shared flow and look at my shared flows down here. And there's my GCP auth that I use in a lot of my demos. So let's look at this in a bit more detail. Less on the summary screen when it's a shared flow, but it looks pretty similar to how you might develop a regular API proxy. Only difference here is it's a shared flow. It's not intended to be deployed so that it stands on its own. So let's look at the steps in here. First thing in here is we're going to check to see if we have a value called GCP token. So we've got a cache in here that's going to populate GCP tokens. So that's our variable value in there, and then there's our key fragment that we go to use and look that up. So if that's already in there, it's going to look it up the rest of these things are all running conditionally on that. So if we look at it down here, we'll notice that there's a condition in there if GCP token equals null. A lot of those steps are all going to have that condition on them. So let's dig in a little bit further here. First step in here, we're going to go get the JWT issuer from the key value map. We're going to go get the private key PEM. And then here we're going to build up that JWT. So very specific process for this. Check out Dino's presentation on this. He's got a lot of details on how this works and why it works, and you can check the documentation. But we've got some Java callout in here. We've got some libraries down here. And then you can see what we're doing here. We're passing these properties in, and then that's going to build us the JWT. We make a call out to the Google OAuth version 4 token API in there, and we're going to send it that JWT. There's the value for it, and then some other things that we want to specify. We'll extract the token value and the expiration time from the response that comes back from that call out. This JavaScript will adjust the time. It makes a little bit to deduct a little bit off there so that the time to live on the cache value is slightly less than the life of the token. If there's an error, we'll return 500 error no token. We're going to stick that into cache in a known value. So we're going to stick that in that value GCP token in there. And we'll look in that cache to see if this exists. And that's going to put it in there so it's available for this step over here on the left. Next thing we're going to do, we're going to take that new token and we're going to assign it to GCP token, which is the value we've been using all along here. And then the final step in this process, so we could execute from the cache right to here, or we could execute all these in between also. But the final step in here is we're going to set a header, and the header is called authorization. It's going to be bearer, and then the value for that is going to be this GCP token that we got from the Google Identity and Access Management System. So that's the shared flow. The way this works is this would get called as if these policies were right in your API proxy. So it makes a call out to this, runs all these steps, but you only see one little arrow, which is the indication it's going to call shared flow. So nice way to reuse code. Okay, so to tie this together, let's look at an application that makes use of this, one that calls out to that token flow, gets a token, and then makes a call to the business flow in order to call an application. All right, so let's look at an example of this. This is an employee directory. If you watch one of my other webcasts, you might have seen me do this demonstration, but basically this is an employee directory service and it takes basic auth. So this is what we're calling on the back end of what I showed in that proxy. And in this case, I put an API proxy in front of it to manage how people consume this, do some analytics on that and things like that. I put some quotas on there, that sort of thing. I also do content-based routing on here. So depending on who you are, I'll route you to different places and that sort of thing. So in this example, though, what I've done is I've added that login to Okta for this. So if I call this and I'm not yet authorized, I don't have a token, it's going to prompt me with a username and password. So let's come in here and try and search and see what happens. I'm going to look for somebody named Smith. Now, I don't have that access token in here, so it says enter your username and password, and I can log in. And this is going to send that username and password into that API flow we were looking at, exchange it for a token, and then my application has the access token, and for subsequent calls, it'll send that. So I log in and it completes my searches. And then, if I do another search in here, I want to refine this. I want to look for some different folks. I can do that, and it will base that. It'll keep sending that access token in there because it's got it. So that's how an application might use this and how we would prompt the user. Transparent to the user, they just have to enter their username and password. What the backend is on the security doesn't really matter. The API developer needs to understand how OAuth works. It's going to be common with other APIs they've probably used. So it should be reasonably familiar to them. But we supply the credentials, and with that, we get a token. So here's the source code behind that application that we just saw. Down at the bottom here, this is basically just an HTML single-page web application using jQuery in this case. So I've got some HTML down here. That puts that search form on there and it shows the results. The results are represented down here, and then we have some code to replace this little segment, this little div down here, with the results of the query. The interesting parts, though, are really the authentication. So let's look at how I do that in here. So we've got a variable called OAuth token. We've got username and password. Those are all blank at the beginning here. We've got some code to wait for everything to load and then process events. So we've got search button, login, things like that. So when somebody presses that search button, what we're going to do is we're going to go grab that search phrase that was in there, and we're going to take the value of that, and we're going to search with that. And we're going to call URL for that and process it. So pass in as application JSON with a header in there, and then with that OAuth bearer token in there. If we are successful, we'll call something called update results. That'll paint the results on the screen. And then if we fail, we're going to check and see, is it a 401 error? And if it's a 401 error, we're going to ask to go get credentials. We'll follow a flow for that. That will go and get an access token. And that's right down here. So there's a few steps in there to display that username and password HTML on the screen. And then once that's done, we make a call to this. So what this is going to do is this is going to call our token flow in there. And we're going to pass in that username and password in there. And we're going to receive back an access token. So OAuth token equals data.access token. So that's where we get that access token, and now that's in here. So the nice thing about this is there's no credentials stored in here. So, I mean, it's just HTML. You can hit view source on here. We don't want the credentials stored in here. So we have a way of going and asking the API to give us credentials. We're supplying a username and password, but we're getting back an OAuth token, and that's what's flowing back and forth in here. So that's a quick summary of the application and how it works behind the scenes. So I'd like to take some questions now. If you have questions, please type them in, and I'll do my best to answer your questions. So what about two-factor authentication? What if your audience is using two-factor authentication? How do you make that happen? So what I've shown here is ways to integrate with a third-party identity management system. A lot of those systems will do two-factor authentication, so they might prompt the user for an extra code, or they might prompt them on their phone or something like that to enter it in. But really anything that third-party identity management system supports, we can do that. We've got a question in here about what if you're in education, K through 12, how do you do rostering of students? I don't have anything specific for that, but it'd be the same techniques in here that whatever the identity management system works, or however you need to authenticate them. So there's probably some third-party application or third-party system that would manage that list of students. So one more question, how can we do this if the security system doesn't have an HTTP interface? What I showed in here, the Google Cloud APIs and along with Okta both have HTTP interfaces, but sometimes you've got something homegrown or something else in there. Apigee Edge does have Java callouts. So it has Java, it has Python, it has JavaScript. If you can hit it through those interfaces, no problem. So really you just need to get an OK signal from that system in order to do this sort of flow. So I've seen from two different users here, they've got more questions. They want to do a follow-up. We'll cover that in just a minute. Yeah, there is a way to reach out to us. You can schedule a call with some of our technical folks, and we can do a one-on-one with you. We'd be happy to do that. And we'll put the contact information at the end there. Another user's asked, we've currently got TIBCO, and it's kind of expensive, and could this replace it? It really depends. So Apigee Edge is focused on the consumption side of APIs. So think about how you do, how would you bring this out to a team of people? So we're not doing integration. We're really talking about how do you run an API program and how would you have that live? So for a lot of the things that you need to do for connecting with the security system and things like that, this covers it quite well. For traditional integration stuff, not as much, but we have talked to a lot of customers, and we have used this to supplement or replace TIBCO in a few different places. So follow up with us, and we'd be happy to dig in with you and see what your specific use cases are and see if that's something we could do. So is there an expiration limit on how long a token refresh token is valid? Yeah, you can specify that. So you can put a limit on there. In this case, I use the system default, which I think is about 30 minutes, but you can specify how many refreshes you get, what the time limit is, and that sort of thing. So yeah, you have control over all that. Take a look at the OAuth policy at docs.apigee.com, and there's a lot of details in there on how exactly that works. One more question I've got in here. If there's more questions, please feel free to type them in. Can we integrate with Active Directory? I hear that a lot. A lot of folks are using Active Directory. So yes, absolutely. If there's a way to talk to it, if you're running on premises, we have a policy for that. And if not, you'd need a way to reach it over HTTP or through a service call out. And really, you're just going to authenticate the user against that or any system in the same technique. So I referenced my colleague Dino's presentation in here. I'll put that in the chat, and we'll also follow up with the resources link. So that's a nice presentation on how to integrate with Stackdriver. Stackdriver is another Google Cloud Platform product in there, but there's a great code example in here of how to do the authentication against Google Cloud, in case that's interesting to you. If you're interested in going into more detail, you can set up a one-on-one session with Mike. We'll put his contact information in there, and you can check for those resources in your email. Another question is there an industry standard for how long an OAuth token should be valid for? I don't know if there's an industry standard for it. I'm thinking, think of like a session timeout you might use on a website or something. Most folks that I see do 30 minutes or 60 minutes for things that tend to be more secure. If it's not so secure, they might do 24 hours or longer if it's not something that is being used as, end user authentication. But I tend to see 30 to 60 minute timeouts on that. That's pretty typical. Really, whatever your security people mandate, usually. Okay, I'm going to move on to the poll questions. We've got a couple poll questions I want to ask about here and query you guys. So we want to know about how familiar you are with API management platforms. Currently use them as a platform and you're a pro? Good job. I'm using a platform but still a lot to learn. I'm debating on getting on a platform. I'm just brushing up my skills and this is just kind of interesting to me. Let us know how you feel about that. We'd love to hear from you guys about what topics you'd like to hear about in upcoming webcast. Let us know what's interesting to you. What would you like to learn about? What would you like to learn, have us talk about? So go ahead and type an answer in there and we'll put those in the queue for future webcasts. Okay. One more poll question. How useful was this? Was it useful, very useful, or didn't really work for you? We'll use this to shape what we talk about in future webcasts. So for next steps in here, we do have another webcast coming up on February 20th. We're going to talk about security. So how do you protect your APIs from common vulnerabilities? We'll look at some of those top vulnerabilities and talk about how to address those. If you do want to follow up with us with a one-on-one session, we can hook you up with some of our technical folks. There's an email there for Mike Lofquist. Email Mike and he'll follow up with you directly and we'll make sure we get that scheduled with the right people. For in-depth tutorial, there's something we call a virtual API jam. That's basically a workshop you can go through, and we'll have you run through a series of examples and labs in there, and you'll build these things for yourself.